Hi, and welcome to Failureology, a podcast about engineering failures. I'm your host, Nicole.
And I'm Brian, and we're both from Calgary, Alberta, Canada.
Happy New Year!
And welcome to a new season of Failureology, or at least a new year of Failureology, which I'm going to call a new season.
So, for those of you that don't know, we recorded our last 3 episodes in November so that we could take a production break. So, yes, our last episode came out on January 2nd, which was technically our first episode of 2022, but we recorded it in November, and I personally was a zombie at that point, and I was just trying to get to December so that I could take a little bit of a break, and I completely spaced on the Happy New Year part. So we're doing it now. Happy New Year, everybody.
Yay! Happy New Year! Happy post-New Year! Happy belated New Year!
Brian, do you do New Year's resolutions?
My only New Year's resolution that I make is I resolve not to make New Year's resolutions. So it was another successful year. This is like 20 years running now. I completed all of my New Year's resolutions.
Well, that sounds fun. I'm the opposite. I don't call them resolutions though, but I do set goals for the year, which are just things that I want to accomplish. I like to make fun goals though. So, I have some professional goals. I have, podcasting goals, but then I also have vacation goals and book reading goals and stuff like that. So I try to make fun goals. I like lists. So, sometimes when I make a list, I put things on it that I've already done just for the satisfaction of crossing it off.
Oh yeah, the checkbox beside something you've already done. We all do it. I think we all do it. I do it. I assume most people do it.
Yeah, so this is just a 2022 list. Do it every year. I've been doing it actually for the last few years. I find it's really helpful. I set goals for the year, but then I also set like 5-year goals or like more big picture goals as well. And it's just to kind of, remind me of what I'm working towards and keep me moving. But yeah, definitely love the satisfaction of crossing stuff off lists.
I did that before I left for work today. I put something on the list I had already finished today just so I could check it off.
It's the best. It's so satisfying.
It is pretty satisfying. We'd also like to say thank you to our Patreon subscribers. For less than the cost of the artificial desk plant that I bought over Christmas, you can hear us talk about more interesting engineering failures. Just think, one artificial desk plant, less than the cost of that, and you can hear us talk about extra engineering failures.
Yes, and there's even more train tangents. I know that you guys need that in your life. We certainly do. Love a good train tangent. There's definitely lots of those on our bonus mini failure episodes.
Nicole, would you say that we get derailed sometimes on the topic in the mini episodes?
Yes, I would. A lot, actually. I see them as less rules to follow. The format is a little more freeform. If we want to get off on a little bit of a tangent, then we do. We have a little extra time. They're shorter episodes, and so I think there's a lot less information. Some of them, if we just strictly talked about the failure, might be 5 or 10 minutes long. So we get on a little train tangent or a tangent of another kind, and it just makes the episode a little bit more fun. Also, there's many ways you can get a hold of us, but we reach out and chat with all of our Patreon subscribers, especially about any failures that they want to hear from us. And we've already got some great ideas from our Patreon group, and I'm really excited to talk about them in upcoming episodes. As you've probably heard us say, we have an ongoing list of failures that we're constantly adding to. I mean, when I started this, I was like, I wonder how long I'll be able to do these episodes for before I run out of content. And now I realize that I could probably do it forever because it's never going to run out of content, which is sad and fantastic at the same time.
We do have some really good episodes coming up this year. I'm very excited about a number of them.
Me too. Especially this one. This one's really cool. I mean, they're all really cool. That's the other thing. We make the list and we look at stuff and we're like, okay, that could be interesting. And we start researching, and every single time I hit a wall where I'm like, oh my God, this is so complicated, or there's a lot going on and I'm having trouble making sense of it and like what's happening. And then by the time I finish, I'm like, oh my God, I have to tell everyone what I just read because this is such a fascinating story and there's so many interesting things that happened. And it's never just one thing. I mean, except for some of the mini fails, but for the regular episodes, it's never one thing. There's always so many things going wrong. as I like to say, it's a series of unfortunate events that lead to these failures. And a lot of people, well, I guess everyone ignores those warning signs. And I just don't do that. You don't want to be on our show. You don't want to be featured in one of our episodes. I can assure you that.
That's like foreshadowing for this episode because we have a repeat offender on this show.
Yes. We'll get to that shortly, though.
Right now, we're going to go on to the engineering news. This week in engineering news, there is a new rail service that's been proposed between Calgary, where Nicole and I live, and Banff, where many, many people vacation and ski and hike and come just to look at the mountains in the summer. It's one of our national parks in Canada, and probably the best known national park, I think, in Canada. Unfortunately, there's no rail service from Calgary, which is a city of 1.4 million people, to Banff, which is about an hour and a half, an hour and 20 minutes away from Calgary to the west.
On top of that, there's no train from downtown to the airport.
That's a different issue, but also part of the same issue.
It's such a... How did we get here? Why is there no train to the airport? I don't understand. This train tangent is brought to you on purpose.
Yes, because it's part of the engineering news this time.
Yeah.
Yeah, it's kind of weird. Like Calgary, the airport's in the northeast of the city. It takes about 20 minutes, half an hour to drive from the airport to downtown Calgary, where a lot of business stuff happened pre-COVID. It's a very similar layout to Denver, where the airport's in the northeast. It's outside of the city. And it's one of the few cities that, obviously I've lived in Calgary, but also, when I travel for work or other things, it's one of the few larger cities that doesn't have a train that goes from the airport to the commercial business district or the downtown core, kind of a built up area where you would expect a train would be. The only way to get downtown from the airport is via taxi or Uber, or there's a public transit bus that you can take for, I believe it's $8 or $10 to get to downtown. But no train, which I feel would be a thing that a city of 1.4 million people would have.
Yeah, but that could change with this Calgary to Banff rail line, potentially, if it goes ahead.
It might. I have my doubts. But we're going to focus on the positives. So like Nicole said, we don't have a train that goes from the airport to downtown, let alone from the airport or downtown out to Banff. There are rail lines that go from Calgary through Banff, but those are used for freight service. So there's no passenger rail service that goes there. Lyricon Capital Limited, who also own the Mount Norquay Ski Resort in Banff, submitted a proposal to the Alberta government with them holding a long-term lease on the train station in Banff. So the new rail line that they proposed to construct was going to twin or parallel the existing CP rail segment as part of a public-private partnership. One challenge that will exist, though, since the route is on CP rail, the passenger service would operate at the mercy of freight transport. And freight transport and freight rail trains, they operate at all hours of the night and of the day. When I lived near a rail line, it seemed they only operated during the night between 1 o'clock and 4 in the morning. But there's this freight is working around the clock. They're moving cars and rail, at all times of day. It's not like there's a time from 9 to 5 where they only move freight. Like it's a constant time that they're moving freight.
And they also move at a different speed, I'm assuming, than the passenger.
I would think they would too, probably at a little bit slower of a speed, or certainly it would take them a little bit longer to get up to speed since they're hauling a lot more tonnage than a passenger rail train would. So right out of the start, I can see this causing complications. There's not a lot of real estate that can be used for train related things. Near Banff, it's through mountainous terrain. A lot of good right-of-way areas that you would use for potential railway or highway development, it's already been used for railway or highway development. So it makes it really tricky to get a train through some of these really narrow mountainous regions.
But if they are able to make this happen, it would significantly reduce the burden of passenger vehicles in the national park. And it would address some labor challenges with all of the ski resorts and tourist attractions in Banff, as well as, of course, reduce emissions because you have less cars on the road. If you live in Calgary or surrounding area, you have likely been stuck on Highway 1 in traffic trying to get back into town on a Sunday evening of a long weekend, usually in the summer when everyone's going camping. It's a huge pain in the butt. You think it's going to take you an hour to get back, and it takes you like 3 or 4.
Your
It's
first
awful.
mistake was going west on a long weekend. The trick is to go south. There is nobody that goes south on a long weekend.
I actually just stopped leaving the city on long weekends. There's no one here, and it's
Oh, for
very
long weekends,
peaceful.
a lot of time I'll go to like the Sheep River drainage, which is just south of Calgary, and it's got very similar views to Banff, and there's nobody there.
Before, you just told everyone your secret. Now everyone's going to be there.
Well, I have to travel to Calgary first.
Brian's second guessing his secret sharing. There's also a large number of people that commute into Calgary from Canmore and Cochrane every day. Cochrane's only 30 minutes from downtown, so that's not, unreasonable, but Canmore is about an hour in good weather, which to me personally seems way too far for a daily commute, but, to each their own. Putting these people on a train would definitely reduce traffic and emissions. Also, if I were these people, I would enjoy that a lot more. It would make my commute a lot simpler. I wouldn't have to be, stuck in the car driving and paying attention to everything in front of me. I would be able to ride on the train, be a passenger. Hopefully it has Wi-Fi. I could work on the train. I could read a book. I could, take a nap. There's a variety of things that you can do on the train that get some other things done so that when you get home, you actually get to spend that time doing, those things that you want to do when you're home. So yeah, I think there's a lot of really good potential with this project. The deal has asked the Alberta government to commit about $30 million annually to the project, but they won't. The deal as it stands right now, they wouldn't have to start committing any money until the rail line is complete as early as 2025.
Yeah, so this project is still in a very early stage. I haven't seen any concrete preliminary plans for it. There's a lot of speculative plans for this. So right now they're looking at 7 stops on the route. So the Calgary International Airport, downtown Calgary, Calgary Keith near Lynx Ridge Golf Club, along Stony Trail, Cochrane that Nicole mentioned, Morley, and Canmore. So Morley is about halfway between Cochrane and Canmore, and then the end destination of Banff would be the 7 stops that they would have on this proposed route. The intention right now is to have the trains from the airport to downtown every 15 minutes, and then from downtown to Banff every 2 hours, or about 10 trips per day. So the cost for Albertans is expected to be about $20, which, depending on what you drive, almost works out to a tank of gas or so, depending on the gas prices.
Yeah, so I mean, I'm in. Sign me up.
The one of the hurdles I can see on this one is at either end, probably at the Banff end, you're still going to need a vehicle to go some of these places. Or if you lived in Canmore and you were commuting to Calgary, if your place of work is outside of the main train line, you still have to be able to commute that kind of final mile to get to your destination or to get to work. But I think this is a good start. It's a good step in the right direction.
I think too, Banff has a pretty good bus system. It's not perfect, but they've got a bus system and it's got a lot of stops and it runs, pretty regularly. If this train line gets built and, it reduces all the cars that are coming into Banff and they do see a lot of traffic on this train route, then I can see them increasing their bus service to accommodate.
Yeah, or, more shuttle bus service or van type service, or, even more car dealership, car rental, sort of things springing up, at the train station. I've traveled before in Europe, obviously before COVID times, but a lot of train stations, especially if you're coming, to the larger train stations, they'd have, bike rentals, or there would be car rental service, car hire service available right at the train station. So certainly I think once the train infrastructure is in place and that got built, then I can see some sort of rental service or increased, van bus service happening.
Ooh, or bicycle rentals. So if you want to check out more about this proposed rail line, there's some links on our website, failureology.ca. There's a link to our website in our show notes. And this is definitely a story that we're going to be following. I really hope this goes ahead. I see any train lines in Alberta as a success. If we got to start laying the infrastructure at some point, and we can always add to it later. But if we can just get started, I think that would be really great. I'm pro train. You know that. You guys, trains are great. Tired of washing dishes?
Dishwasher broken?
Flip the dishes over. There's a second side to those.
At least the plates.
We can't help you out with the bowls, but if it's the morning and you have no bowls, you're already in a bad spot if you wanted cereal.
Use a mug or something. You're probably still half asleep anyway. Who's going to judge you for eating cereal out of a mug?
We got your back. Flip the dishes. Now on to this week's engineering failure, the 3 Mile Island accident. Yes, another nuclear accident. Well, I mean, bad for them, good for us. These ones are really interesting. This one began at 4 a.m. on March 28, 1979, which took place 7 years before Chernobyl. 3 Mile Island was the most significant nuclear accident in U.S. history, ranking a 5 out of 7 on the International Nuclear Event Scale, which means that it was an accident with wider consequences, which is kind of big. Chernobyl, which we covered in episode 13, and Fukushima Daiichi in Japan, which we intend to cover in the future, are the only nuclear disasters to rank 7 out of 7 on the International Nuclear Event Scale. So this one was a 5 out of 7, still pretty bad, but not the worst.
I feel like anytime your power facility is anywhere on the International Nuclear Event Scale, that's not good.
I wonder at what number on the scale is the nuclear unit repairable such that it can go back into operation. There must be a number, maybe like 1, 2, and 3 are repairable, and anything worse than that is not. Maybe if you register on the scale, you're not repairable. Maybe I should have looked that up before.
I feel like anything is repairable with a large enough purchase order.
Oh boy. I don't know. We'll see. This is pretty bad. So
this one is pretty bad.
So the cause of the accident was related to a stuck open pilot-operated relief valve, which allowed a large amount, almost all, of the nuclear reactor coolant to escape the system, which would be radioactive short-term. Training for the 3 Mile Island or TMI reactors did not prepare operators or management to recognize the loss of coolant. And there were also a bunch of design flaws, such as, quote, a cacophony of alarms, an inconvenient arrangement of instruments and controls, and the absence of clear indicators for coolant inventory or the position of the stuck open pilot-operated relief valve, end quote. So there were a lot of things going on. A lot of things went wrong. And this was not that long after what we'll call TMI-2 or 3 Mile Island-2 reactor came online.
3 Mile Island is located in Londonderry Township, Pennsylvania, on the Susquehanna River south of Harrisburg in southeastern Pennsylvania.
So based on Google Maps, even though the station is closed, which TMI-2 has been closed for a long time, TMI-1 has only been closed for a few years, you can still see the full plant in satellite view, which is really, really cool, I thought. And you can even see the caps they put on the cooling towers for TMI-2. So you'll notice it's the one on the south end. But you can see the whole plant, the island, where it sits in the river. Really, really interesting. I definitely went down a rabbit hole and was looking at the map for probably half an hour.
Oh, that is really cool. We can still see this, and you can tell that TMI-2 has been capped.
Yeah, I mean,
it's really neat.
TMI-2, when this happened, Google wasn't even a thing. Can you even remember what that was like before Google?
I can, because I am old, so of course I remember this. I remember when we navigated with paper maps, and we liked it.
There was no blue dot, guys. We didn't know where we were on the map. That was the worst part, the hardest part. You had to follow the map to keep track of where you were on it. And if you lost track of where you were, you had to find some kind of cross street so that you could find yourself on the map again. The worst. Honestly, the worst.
It's an important skill to have. So the next time you take a road trip after the COVID situation kind of resolves itself and you feel safe to travel again, practice that. Turn off your Google Maps. Figure out where you want to go. Pull out an actual map. I think they still print maps. And try to navigate yourself to your destination on a paper map.
No, thank you.
The nuclear generating station had 2 separate units called TMI-1 and TMI-2. So TMI-2 is the star of today's episode, being the reactor that suffered a partial meltdown. But TMI-1 also had some less severe incidents that we're going to talk about a little bit later on in the show. For some quick background on how the station and the reactors operated, TMI-1 was owned by Exelon Generation and TMI-2 was owned by First Energy Corp.
So Both reactors were pressurized water reactors, and they were designed by Babcock and Wilcox with a net generating capacity of 819 megawatts for TMI-1 and 906 megawatts for TMI-2. Unit 1 came online in 1974, and Unit 2 came on in 1978, 1 year before the accident. I don't know exactly how much TMI-2 cost, but it was a lot of money. And this accident happened 1 year after they built it, and it's never ran since. So that's a
really bad return on investment.
It's a really bad return on investment. On top of, they probably got fined, and they probably had to do cleanup and the investigation and so on and so on and so on. So not only did they lose their full investment, but they also had to spend money for sure. Silver lining, Unit 1 was offline when the accident occurred with Unit 2. It was down for refueling, and they brought it back online in 1985, which was several years after this accident. We're going to get into some of the aftermath later, but nuclear is not super popular, especially amongst North Americans, it seems. And so when TMI-2 had this event, there was a lot of backlash from the public. And so it wasn't until 1985, after overcoming a lot of opposition, that they turned TMI-1 back on. And it actually continued to operate until September 20th, 2019, and then before it was decommissioned. But as I mentioned, Unit 2 was shut down after the accident. They never turned it back on. So the 3 Mile Island reactors are different from the RBMK reactors that are used at Chernobyl. RBMK is the Russian version or the Russian model. They're pretty particular about, they like to do things different. As you'll know from our International Space Station episode, they have their whole own space station that has different docking mechanisms and it's constructed completely different from the one that everyone else uses, which is kind of weird. We just want to be friends.
Okay, different specifications were an issue in the Kursk episode as well.
Yeah.
And the way that the diving bell and some of the other rescue equipment that NATO countries had, and they couldn't connect and attach to the Russian submarine, which is unfortunately led to a lot of people losing their lives.
Yeah, but the concept for the 3 Mile Island and the RBMK reactors is pretty similar. The nuclear reactors use the heat generated from the fission chain reaction to create steam, which turns a turbine and generates power. The main difference being that the RBMK uses graphite instead of water as the moderator, which is less stable than the pressurized water reactors used at 3 Mile Island. So the 3 Mile Island reactor was thought to be much more stable and safe than the RBMK reactors were. Both units, both TMI-1 and TMI-2, had a closed cycle cooling system for its main condenser, which just means that there's a loop of water that's continuously flowing through that system. And they're not bringing in fresh water all the time. They keep that loop continually closed, and then they use a heat exchanger to remove the heat from the loop as the loop gains heat from the reaction.
Sounds like the radiator system in your car.
Yes. They also each had 2 natural draft cooling towers. So if you do happen to look this up on Google Maps, you'll see what you'll see is the natural draft cooling towers. They look like 2 large cones with holes in the top. Those are the cooling towers, and there's 2 for each. So the TMI-2 is on the south side, and you can see the caps on it, and then TMI-1 is on the north side, and at least the map that I was looking at, which may or may not be current, it might be a couple years old, there's no caps on TMI-1. When they do need makeup water, they draw it in from the river to replace the water that they lose to evaporation in the cooling tower. And then this water is then used for the service water system, which cools auxiliary components and removes decay heat when the reactor is shut down.
Sounds like a pretty good design.
Yeah. So, when I researched Chernobyl, I was really confused. When you first start looking at it, nuclear reactors seem really, really complicated. But then you start looking at the schematics and you watch a few YouTube videos, and certainly not a nuclear engineer or a physicist by any means. But, once you kind of start looking at it a little bit, it's not so complicated that you can't wrap your head around it. I mean, they're really just using a chemical process to generate heat and then using that to make steam and spin a turbine. And then they have to control how much heat is created so that it doesn't overheat. And so they have to use a cooling system to cool it down. So it's complicated, but once you start looking at it, I don't know. I feel like I think I got a feel for it now. This is my second nuclear reactor episode that I've done and I've researched. And so, yeah, I don't know though, if you're a nuclear physicist and I'm wrong, tell me. I want to know. Come on our show. Teach us.
Or if you're just a nuclear physicist, just come on our show, because that would be really cool to have you on our show.
Yes.
On to the accident, though. So on March the 28th, TMI-2 was running at 97% with the first reactor shut down for refueling, like Nicole mentioned. So the sequence of unfortunate events starts very early in the morning at 4 a.m. and 37 seconds, although the initial cause of the accident happened approximately 11 hours earlier. So there are sophisticated filters that stop minerals and impurities, as well as decrease corrosion rates in the water that pass through the steam generator system, which is important to have all these things removed, as you want the highest quality water, basically distilled water, ionized water. And the reactor has 3 loops that this would pass through. So the primary loop flowed between the reactor and the steam generator, which is like a giant heat exchanger. The second loop flows between the steam generator and the turbine, and the third, or the tertiary loop, flowed between the turbine and the cooling tower. Blockages in the sophisticated filters were common and usually fixed easily with compressed air, kind of the same way that you would clean out a filter or your computer fan. I mean, you just blow compressed air on it. But this time, that wasn't working so well, so the operator blew the compressed air into the water and let the force of the water clear the blockage. When they did this, a small amount of water snuck through a stuck open check valve into an instrument air line. This eventually turned the feed water pumps, condensate booster pumps, and condensate pumps off around 4 a.m. So all around bad news bears. So when all these pumps all turned off, the failsafe was in there, the turbine tripped and stopped working.
Which, okay, so we've got more, but just for a second. So the water sneaking through the stuck open check valve into the instrument airline, I mean, shouldn't have happened for sure, but, stuff happens. But they seem to be completely oblivious that these pumps failed. And I don't understand why.
There should have been some sort of warning system, whether it's auditory or whether there's some sort of, I'm going to say SCADA type control system, or there's feedback to the control room that, these pumps are off. Like it seems like that's a fairly important thing, that, if your pumps trip off, that you want to figure out, well, first of all, you want to know that they're off. And then second of all, maybe somebody should go and figure out why they turned off or if they need to be reset. And, I understand that this is, almost 50 years ago. So some of the technology that we take for granted didn't exist at that point, or it certainly wasn't in widespread use. Things that we take so commonly, things like, internet and, kind of fly-by-wire stuff and systems monitoring, that didn't really exist at the time that this incident happened. But I would think that in a system like this, it's, fairly critical if things go wrong, that there'd be some light or some alarm in the control room that would go off to alert them that, not only one pump had failed, not 2 pumps, but 3 pumps had failed.
Yeah, so we are going to get to that a little bit later. There are some indicators, but they were hidden either by other things, or I think one of them was even hidden by like a keychain tag that was on a different key.
Yeah, one of the maintenance tags basically blocked the light indicator. But we'll talk about that in a little bit. We're getting a little ahead of ourselves, like we usually do.
Yeah. So since the pumps were off, the water in the coolant system quickly turned to steam. Shocking. And the pressure in that system eventually rose so high that it tripped the high pressure set point at 162.4 bar, or 2,355 psi. This happened 8 seconds after the pumps turned off and the turbine tripped. So the pumps go off and the water flashes to steam in 8 seconds, which just is a really good indication of how hot this reactor is. This caused the pilot-operated relief valve to open, which is good. This is a failsafe. This protected the system from overpressurizing and causing some kind of steam explosion.
Yeah, that's what relief valve do. It's working as designed, as intended.
Yes, and it did. It reduced the pressure. But as well, the reactor ended up tripping and the control rods fell into the core, which stopped the nuclear chain reaction and the heat generated by fission. But it doesn't quite work like a light switch. So just because the control rods fell into the core and the chain reaction was essentially stopped doesn't mean that you completely stop the reaction, and it doesn't mean that you're not still producing heat. So the reactor is still producing what's called decay heat, and this happens until they're able to fully shut down and, some time has passed. So it's not operating at full power, but the decay heat is about equivalent to 6% of where the unit was at before it went down.
Even though the relief valve was open, to limit the buildup of pressure, heat was still being produced that needed to be dealt with to prevent a reactor meltdown. Not to worry though, when the feed water pumps tripped off, 3 emergency pumps started. That's good. Except the valves in 2 emergency feed water lines were closed, and no water could get to the reactor.
That's bad.
That's bad. That's not good.
No,
that's bad.
Bad.
So, the valve position light for one of those closed valves was blocked by a maintenance tag. The other just got missed by the operator. So the closure of these valves was a violation of a key Nuclear Regulatory Commission rule, and this was later singled out as the key failure by Nuclear Regulatory Commission officials. 15 seconds after the turbine trip, 15, it's 1-5, seconds into this accident, not very much time at all, the pressure in the coolant system drops and the relief valve is signaled to close, except it's stuck and coolant water is being released. The relief valve indicator design was later blamed as one of many design flaws, as there is no feedback to the operators on the valve's actual position. That seems like something you would want to have feedback on.
For sure. So this is something we deal with in building automation quite often, although, of course, we're not controlling a nuclear reactor. But there's essentially 2 different types of control loops. There's an open loop, which sends a signal to the device to complete a specific action, and then a closed loop, which also sends a signal to the device to complete that action, but then the device reports back with its status to confirm whether or not it did successfully complete that action. So the relief valve in TMI-2, based on what we've read, is an open loop type control, and it doesn't actually provide feedback to the operators to confirm that the valve is in the position that it's supposed to be in, which seems like a pretty huge oversight. Relief valves are pretty simple devices. I wouldn't say they're super complicated, and so maybe that's why they didn't think they needed a closed loop type control. But clearly we can see here that they did. They definitely did.
Less than a minute after the turbine trips, the level in the pressurizer begins to rise, but the coolant system pressure was falling. The pressurizer, based on the schematic, appears to be some type of expansion tank that essentially creates extra volume for the system when pressure starts to rise, until such a point that it must be relieved. We know now that this was a loss of coolant accident, but at the time, the operators would have expected to see a rise in cooling system pressure and pressurizer level if there was a loss of coolant accident, and they didn't know what to do when the 2 parameters went in opposite directions. It's got to be a really confusing situation.
Yeah, it's, we talk about this a lot with airplanes. When you're in an airplane and an accident happens, you can't just pull over to the side of the road. Nuclear reactors aren't quite the same, but you can't just walk into the reactor and see what's going on. It's not like you're in a mechanical room and you've got all these gauges and valves and you can play with stuff and do stuff and try to troubleshoot what's going on. It's still a nuclear reactor. You're still dealing with unsafe materials, radiation exposure, a lot of unknowns. And you're kind of just doing the best you can.
Yeah, so since the operators didn't know the backup pump valves were closed and there was no water being introduced to the coolant system, they actually thought the system was being overfilled and they turned off the emergency cooling pumps. The relief tank that caught the discharge from the pilot-operated relief valve that stuck open eventually overfilled and caused the containment building sump to alarm at 4:11 a.m., so 11 minutes after the start of this. The higher than normal temperatures in the relief valve discharge line and the reactor temperatures and pressures were a clear indication of a loss of coolant accident, but the operators ignored it.
At 4:15 a.m., the pressurizer relief tank ruptured and radioactive coolant began to leak out into the general containment building. At 5:20 a.m., so 80 minutes after the start of this accident, there was still slow temperature rise and the cooling pumps began to cavitate because there's no coolant water in the system. It would all turn to steam and it all went out that open relief valve that they didn't know was stuck open. So the operators then turned off the pump and they, quote, believed that natural circulation would continue the water movement, end quote. I don't even know what that means. What does that even mean? Natural circulation. That's not a thing.
I mean, I feel there's got to be some sort of mechanical induction for the circulation to happen. I mean, this is not a waterfall, like a whirlpool at the bottom of a waterfall where all of this is just kind of going on. Yeah, I think there's got to be some sort of artificial or mechanical type circulation. I don't think there's a natural circulation in a nuclear reactor.
No. So at 6 a.m., the heat was so intense that it melted the nuclear fuel rod cladding and damaged the fuel pellets, releasing radioactive isotopes to the reactor cooling and produced hydrogen, which was believed to cause a small explosion in the containment building later on that afternoon. Also at 6 a.m., there was a shift change in the operators. One of the replacement operators noticed that the relief valve discharge was high and used a backup valve to stop the release of coolant. But it was already too late. At this point, 2 hours later, they'd already lost 120,000 liters of coolant. It's a lot of water.
That's a couple bathtubs worth.
Just one or two. At 6:45 a.m., 165 minutes after the turbine tripped, radiation alarms activated and the radiation levels in the primary coolant water were around 300 times what they were supposed to be. But they still don't know what's going on. It wasn't until 6:56 a.m. that a plant supervisor declared a site area emergency, and then 30 minutes after that, the station manager announced a general emergency. So almost 3 hours after all of these things happened, they finally realized that they were in a state of emergency, which is...
That seems like a really long time to, before you announce a state of emergency.
Yeah, so the part that I guess I find confusing, so Okay, so you didn't know you lost coolant. You didn't know that the pumps weren't working properly, that you had some valves closed, you had some valves stuck open. You didn't know all that stuff. Fine. But you knew the turbine wasn't working. You knew the reactor shut off. Even if you didn't get alarms on those things, you weren't producing any power. And those things all happened, not that long after 4 a.m. So what were you doing for almost 3 hours? I don't quite understand. Accidents happen, for sure. Sometimes things happen. I wouldn't say they're unavoidable. This was clearly preventable. But stuff does happen. I just don't understand. It gets worse. So the confusion of the operators as they tried to help local and state agencies determine what happened and the severity of the exposure only made things worse. They eventually brought in the Nuclear Regulatory Commission, but they couldn't make heads or tails of it either. Not to mention they were organizationally ill-prepared to handle this type of emergency, which also cause for concern. The Nuclear Regulatory Commission was not organizationally prepared to handle a nuclear accident, which I think is a big issue.
This seems like something they should be really good at.
Yeah, that's kind of your job.
I don't know how to handle a nuclear, accident or incident because I don't deal with nuclear power projects. But if you're the Nuclear Regulatory Commission, which I assume is made up of lots of very smart people that have a lot of experience with nuclear related things, they should probably know how to handle an emergency situation.
Yeah. So this is 1979. So this is 7 years before Chernobyl. This is several years before Fukushima. I'm sure that there may have been other nuclear accidents before then, but maybe this is one of the more earlier ones and they were definitely ill prepared. I assume they learned some things on this one and they learned a lot after Chernobyl. Yeah, again, this is almost 50 years ago. So I don't think they're so ill prepared today. But I also think that, being prepared for emergency is really, really important. It's one of the reasons that we do things like fire drills. We have to be prepared. Things like this are kind of unavoidable. Thinking they won't happen is just complacency and it sets you up to be, so ill prepared for this type of thing. And then you kind of don't know what to do. And it just kind of makes the situation worse.
Yeah.
The confusion in this scenario was so bad that it took years to figure out what happened. It wasn't until they opened the reactor vessel, physically opened it, that they were able to determine that by the time they called reinforcements at 8 a.m., which was 4 hours after the accident started, that half of the uranium fuel had already melted. So there was so much damage that happened and so much risk that they took on because they waited so long to call in reinforcements because they didn't really know what was going on, which is, it's really unfortunate.
TMI-2 was online for 3 months. As a result of this accident, it was too badly damaged to resume operation. They started some cleanup in August of 1979, and that ended in December of 1993 for a cost of $1 billion US dollars, which is pretty much $2 billion in today's US dollars. As a result of this, an anti-nuclear movement sparked worries about health effects following the accident, but epidemiological studies looking at cancer rates in the areas surrounding a plant since the accident didn't really show a statistically significant increase in the rate of cancer. However, that said, $25 million was paid in insurance settlements to people who then essentially signed a non-disclosure agreement, or an NDA, not to discuss their injuries or any litigation that arose from this accident. In 2010, the Nuclear Regulatory Commission announced that the electric generator from the Unit 2 reactor will be used at the Sharon Harris nuclear plant in New Hill, North Carolina.
So I just want to touch on a couple of things after we've kind of gone all over that. So I'm pro-nuclear. I think it's a really good option. It produces a lot of reliable power in a small footprint with a reasonable capital expense.
I'm also pro-nuclear for those reasons as well.
Yeah, so, I mean, is it a perfect system? No. Are there some kinks that need to be worked out? Definitely. For example, what do you do with the radioactive material once it's no longer strong enough to be used in the reactor, but still radioactive? Speaking of which, this has been a pretty big discussion going on on the Bruce Peninsula in Ontario, just west of Toronto. Right now, this is something that they're trying to deal with. There's the Bruce nuclear plant that has a similar problem, and I don't think they've really worked out a solution for what they do with that radioactive material. I also think that 3 Mile Island, as well as Chernobyl, are clear indicators that reactor design and operator training need some pretty significant improvements. I've clearly never worked a nuclear power plant, but I think you need at the very least a nuclear engineer and nuclear physicist sitting at the operations desk 24 hours a day. What I've noticed consistently across at least the two failures that I've looked at so far, there seems to be a lack of understanding of the science behind the design.
Yeah, like the operators just don't have a full understanding of the science and the design principles that have gone into a lot of the design, where they can understand the power plant design and how everything works on the same level that a nuclear engineer or nuclear physicist would. Operators are great people. I've worked around a number of gas plant operators. They're very good at what they do, but they don't have the same level of schooling that a nuclear physicist or a nuclear engineer would have for a position like this.
Yeah. Anyways, it's just food for thought. I still think nuclear power is a good idea. It just needs some serious work. I myself already have a full list of the world's problems I'm trying to solve, so I'm going to leave this one to the experts to figure out.
All right, as we promised, TMI-1 also had some incidents which we'll touch on briefly here. Fortunately, or unfortunately, I'm going to say fortunately, none of them were as interesting or catastrophic as TMI-2.
Fortunately for them, unfortunately for us.
Yes. So in 1993, a man drove his car past the checkpoint, broke through the entry gate, crashed through a secure door, and entered the Unit 1 turbine building. He hid in the turbine building for 4 hours before being apprehended. I just like to say I'm impressed by how well his car held up. Like, he's gone through a lot of things in a vehicle. I mean, secure doors and entry gates and past checkpoints, and his car was drivable through at least 3 of these. And then he's able to hide in the turbine building for a few hours. Next incident in 2009, which is a release of radioactive material, occurred inside the containment building while workers were cutting pipes. 20 employees were treated for mild radiation exposure. So again, neither of those on the same level of catastrophe as TMI-2, but there were some incidents that happened with TMI-1.
Yeah, I mean, we have to talk about them. We're curious. We're very curious people.
It's like the too much information part.
Right? I know. As I'm reading our show notes, every time I see TMI, I'm thinking too much information. And I'm like, no, it's 3 Mile Island.
I thought the same thing too.
So I just want to add a little bit more here before we wrap up. I find nuclear disasters fascinating, as I'm sure you can tell, but also really challenging. I learn a lot as I research them. And as I mentioned before, I usually hit a wall at some point during research where I have no idea what's going on. And I have to teach myself, in this case, the basics of nuclear fission and reactor design, just so that I can understand what went wrong. But I pushed through, and by the time I get to the end, I'm completely enamored and can't wait to do another one. So don't you worry. We have Chalk River and Fukushima Daiichi on our list, and we plan to cover them in an upcoming episode real soon.
Yeah, I believe Chalk River came from a listener suggestion as well.
It did.
Yeah. So thank you so much. You know who you are that sent us Chalk River. It's been added to the list, so we will eventually get to it this season. I'm very excited about it. To do Chalk River, as well as Fukushima. So there you have it. Some significant design flaws and operator errors led to the meltdown of 3 Mile Island Unit 2 3 months after it came online. Even though this accident was not the worst nuclear disaster to take place, it was still really bad and completely preventable. We hope nuclear reactor manufacturers and operators around the world took note of what not to do.
For photos, sources, and an episode summary from this week's episode, head to failurology.ca. If you're enjoying what you're hearing, please rate, review, and subscribe to our show so more people can find it. If you want to chat with us, our Twitter handle is @failurology. You can email us at thefailureologypodcast@gmail.com. You can connect with us on LinkedIn, or you can reach us on our Patreon page. Check out the show notes for links to all of these. Thanks everyone for listening. And tune into the next episode where we'll discuss United Flight 232. Yes, another plane one. You know how Brian and I love those, especially Brian.
It might be a two-part one. I have a lot of things to say.
Yeah, we were discussing it the other day, and I think we chatted about it for almost an hour. So interesting. So United Flight 232 was a DC-10 plane whose rear engine catastrophically exploded, cut all the hydraulic system lines, resulting in a complete loss of flight controls. So that'll be a fun one. Make sure you tune into that one. You don't want to miss it.
Or just download it, since this is not 1980, and you can download and listen to them on your own time.
But that's all for us for now. Bye, everyone. Talk soon.